We're on 4B.4, part 2, interpreting negative determinants, okay? The objective here is to apply linear transformations to a unit square and determine the area of the image. So here we have two linear transformations. We have T, X, X, Y, 2, 3, 1, 4, and we have L, X, Y, 3, 2, 4, 1, okay? What we're gonna do is map it out, but we're doing it with our unit square. So it says we're using the unit square. So remember, for our unit square, it's made up of 4 points, correct? Those 4 points are just zeros and ones. So we have 0, 0, 0, 1, 1, 0, and 1, 1. Does it matter the order I write them in for my unit square? No, it does not. Okay. And it wants us to apply these transformations to each one of them. So to find the first one, we're doing the transformation of x, y. We have t. So the transformation for t is going to equal 2, 1, 3, 4 times 0, 0, 0, 1, 1, 0, 1, 1. The transformation for L is going to equal 3, 2, 4, 1. And we're transforming our unit. So 0, 0, 0, 1, 1, 0, 1, 1. Okay, so for this one, remembering what this means, we're going to write it in coordinate form. So in coordinate form, we have t of x comma y equals, and remember, these are your coefficients of your coordinate form. So it's 2x plus 3y comma 1x plus 4 for L. In coordinate form, it equals, 3x plus 2y, comma 4x plus y. No, I got ran out a little space there. Okay, so we're going to find these points. Remember, we've learned 3 ways of finding the points, right? Well, 4. We can take each ordered pair and plug into the coordinate function. That's option 1, correct? We can take each pair here and multiply by hand. So 2 times 0 is 0, plus 3 times 0 is 0, and keep going, correct? So that's option number 2. Option number 3 is we can use our TI-84 and plug in the matrices. And option number 4 is we can use desmos.com/matrix, correct? So we have all these means of finding the vertices. Does it matter which one we use? No. Okay. So for me, I'm going to go ahead and use Desmos, and you can use whichever you want. Please feel free to work ahead. So I'm going to go here. I'm going to type in desmos.com/matrix. Enter. And here is my window. I'm going to put in a new matrix. My first new matrix is going to be the transformation for t. And that's going to be 2, 3, 1, 4. And I'm going to put in B, which is going to be the transformation for L. And that's going to be 3, 2, 4, 1. And then I'm going to put in my unit square. My unit square is a 2 by 3. No, square 2 by 4. Duh. 0. I don't remember. I did 0, 0. Then I had 0, 1. Then I did 1, 0. And then I had 1, 1. So those are the 3 matrices that I'm going to be working with, right? To find the product of transformation t, we're doing A times C, and we get 0, 0, 3, 4, 2, 1, 5, 5. Yes? Then to find the transformation B times C, gonna hit enter. And what do you notice? What do you notice about these vertices? They are what? They're the same. They may not be in the same order, but are the vertices the same? They are, okay? So there's a reason for that. So we're gonna go ahead and plot it out just to show you that you're gonna get the same output. So we had 0, 0. Then we were at 2, 1. Then we had 3D, was it 3, 3, 4? And we had 5, 5. So I should have A, B, C, D, sorry. So our A prime is still here. 0, 1. What happened to 0, 1? 0, 1 moved here, right? Was that 0, 1? No, I think it's at the bottom. Sorry. We had our B prime, C prime, and D. I think I did that right. We'll double check what the labels are. But either way, it's going to be the same image, okay? The biggest takeaway here is going to be from us analyzing our determinant. Do y'all remember how to find the determinant? Perfect. We're going to be cross multiplying and subtracting. So to find your determinant, it's your notes. To find our determinant, it equals, we're going to cross multiply. So first cross multiply. And then we subtract. So when we find the determinants of t, so finding the determinant of t, I'm here, right? It's going to be 2 times 4 is 8. 1 times 3 is 3. Its determinant is 5. To find the determinant of L, 3 times 1 is 3. 4 times 2 is 8. And we end up with a -5. So we ended up with the -5. Okay, because we end up with the -5, what that does is it just changes the orientation of it, right? It just makes the numbering, the lettering be different on each one. However, does it change the size? No, it just changes where each point is going to reside, okay? So if I had did these correctly, which I know I did not on the lettering system up here, but if I had this instead of A, B, C, D, this one would probably be the opposite, A, B, C, D, okay? It just changes the order of the vertices, but it doesn't change the size, okay? Then that's different. So that's totally different. Those are two different determinants, okay? So a lot of times when we take the determinant, especially when we're finding the area, we're going to take the absolute value of it. Does that make sense? So we're going to take the absolute value of our determinants to make sure that when we're determining the area, it's going to always be positive. Does that make sense? Because can you have negative area? No, but that's how we find our area, right? Absolute value, area? Determinant. I didn't write the word determinant there, though. So your area equals the absolute value of the determinant being multiplied, okay? And I didn't write my final solution. I forgot already. It was 0, 0. What was it? What was T? The first one? 0, 0, 3, 4, 2, 1, and 5, 5. And then what was the second one? 0, 0, 2, 1, 3, 4. Okay. 5, 5. Perfect. Thank you. Okay. So again, when the vertices are the same, this is going to happen, right? They're going to create the same shape. It's just that one is positive and one is negative. And that's because they have opposite determinants. Cool? Yeah. All right. So we're going to do it as a class. We're going to create our own transformation. So we're going to decide on randomly select an integer between 2 and 10. Have your partner randomly select another integer between 2 and 10, and use these values as the width and length of use these values as the width and length respectively of a rectangle. What is the area rectangle you and your partner created? Okay. So it's just like when we talk about numbers and values, it can vary. You can say, okay, 1, 2, 3, 4. It's going to go back and forth, right? I feel like there should have been more to this, but that's all it literally says to do on your paper, isn't it? What does your all's instructions say? Because this one.
Graph it and then determine the image. Oh, yeah, determine the image of the rectangle and then
It gave you a linear transformation?
Yes.
Oh, I need to just switch to the other slide, is what it was telling me. Got it. I knew that. So choose a point. What are we going to do? What's going to be our length and our width, class? 3. We got 3 by what? A 3 by 4? That is a rectangle. Length and width. 3 by 6? Or 6 by? Why are we making our numbers bigger? Well, I don't want to erase. I'm just gonna leave it. So what's the area here? 12. Well, I'll say class. Don't embarrass me on this recording. All right. So now we're going to go create it and come up with some dimensions. We'll come up with some ordered pairs. So graph your rectangle in the coordinate plane so that one vertex is at the origin and 2 of the sides lie along the X and Y axis. So we chose 3 by 4. So we're at 0, 0. And our width is 3. So we're going to go 1, 2, 3. And we're going to go, our length is 1, 2, 3, 4. So here is our little rectangle. From here, can we write that as a matrix? Okay, so let's write the matrix of our rectangle. What is the matrix of our rectangle? 0, 0. 3, 0. 3, 4. 3, 4, and 4. All right, and now it wants us to transform it by this. So we're going to transform it using this matrix. So if I'm transforming it, what am I going to do? Multiply. So we have 2, 1, 3, 4 times 0, 0, 3, 0, 0, 4, 3, 4. And again, how you transform it at this point is 100% up to you, right? I'm just going to wait for y'all to tell me the answer. Because I did not go up to 4, no one said anything to me. Y'all are going to let me be embarrassed. I didn't go all the way up to 4. 1, 2, 3, 4, 1, 2, 3. I was like, why is my rectangle so short? Big U's.
Doesn't matter what order we put them in.
Nope. It is not.
Because,
All right, we're ready? What do we get?
yeah,
0, 0,
3,
6, 3,
12, 16,
12, 16,
18.
and 18, 19. Okay, so this is what our new image would be. So I don't even know if we can fit it all in here. I'm gonna try. So we're at 0, 0. Then I gotta go 6, 1, 2, 3, 4, 5, 6, 1, 2, 3. Okay. Then I gotta go 12, 6, 7, 8, 9, 10, 11, 12. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, I made it. 7, hold on. 16, 12, 13, 14, 15, 16, 17, 18. Then up through from there. 1, 2, 3. Oh, look at that. Okay, pretend that I went through that point. So there is my new rectangle to the best of my ability with my little eyes squeezing in here. Now let's talk about the area of this rectangle. Okay, so to find the area, remember, we don't want to do it the long way, right? So in order to find the area, we have to find what was the determinant of our transformation and multiply that by the area of our original. Does that make sense? So the determinant here is what? What's our determinant? 2 times 4 is 8, right?
5.
So we have 8 minus 3, which is going to be our 5. And then it's multiplied by the area of the original. And what was the area of our original? 12. So we have 5 times 12, which means that this is 60 square units. Now, we can go back to that part that we skipped, and we can do it the long way so you can appreciate the shortcut if you feel the need in your spirit to do so. No one? No one feels it? Okay, that's cool. It's cool. Just thought I would offer it. But is that doable?
Yeah.
To transform, to find determinant, find the area? Do you see how everything's slowly building on top of each other? Cool? Are we good on part 2? All right, y'all are awesome.